So the definition of a limit is the y value the function approaches as x approaches whatever that given value is. Okay. Now, let's start off with an equation. In order to find the limit as x approaches -4, you would simply substitute in 4 for x into that function. So if we take 2 times -4 plus 8 over -4 minus 9. And again, I just did a substitution. I just substituted in the x value. You would get 0 over -13. So is that 0 or is that undefined? 0 divided by -13. 0. So your limit would be 0. It's undefined when you try to divide by 0. All right, so for the second one, B, we're going to substitute in what? What limit are we approaching as x approaches what? 2. So let's substitute in our 2. So that would be 2 squared plus 3 over 2 squared minus 6 times 2 plus 8. So that would be 4 minus 12 plus 8, which is 7 over 0. And what is 7 divided by 0? Undefined. So what that means is, at that point, we have a discontinuity. So there is some kind of discontinuity at x equals 2. Whenever you get an error like that, that just tells us that we have a discontinuity at that point. All right, go ahead. Let's do C. The limit as x approaches -1, so that would be -1 squared plus -1 minus 2. That's all over -1 squared plus 6 times -1. All right, take a moment and see what you get there. And what do you all get? What'd you get? 2 over 7. Anybody else get 2 7s? 2 over 5. Anybody get 2 over 5? We got 2 over 5. 1 minus 6. Yeah, that's 5. Positive or negative 2/5. So that means your limit would be 2/5. All right, now just a recap over in behavior. Whenever it's asking you for infinity or negative infinity, that's an in behavior question. So what this is asking you is, when it says positive infinity, is what is the arrow doing on the right? And I don't know if you remember from Algebra 2, but your right arrow follows the lead of your leading coefficient. So your right arrow is the same as the leading coefficient, which is actually what we're talking about in integrated. So because this is a positive 4, that tells me that the arrow on the right will go up. So that means that my end behavior, thank you, because the arrow is going up, the end behavior will be positive infinity. Hi, thank you. Okay, so this is at the end of class. Okay, so now let's talk about limits. Now, I don't know if I put this on there at the top, but a minus sign after means from the left. Is it there? If not, you might have to write this in. Okay, so if I say X approaches A, with that little minus sign after it means it's coming from the left. The plus sign, notice that it's after it means it's from the right. And if it just says at A, that means at that point. The left and the right must be the same. If not, the limit does not exist. So I'll give you a moment to copy that information down, and then we're going to just practice looking at graphs and determining the limit.
Did we write anything for question B, like besides the
It was infinity because it matched positive 4. Because 4 was positive, the limit was also positive. All right, so this first one, A, is just asking for G of 2. That's not a limit. This is just asking what is Y when X is 2. So notice here we are at 2. Which one of these points am I going to look at to get the value at 2? Is it the open circle or the closed circle? Which one do you think I'm going to look at? The closed circle. And this is counting by a half, so this is 3. So this equals 3. Now the limit, though, that's different. Okay? The limit is saying this means from the left. Does everyone see how it has that little minus sign? This means the left, from the left. So if I were to draw an invisible wall at 2, if I were to draw a wall, where does it hit the wall on the left? The left side of the wall, the left side, where does it hit the wall? At Y equals what? 1. Because this will be the left and this is the right. So on the left side is hitting here at 1. But on the right side, it hits here, which is 2. The limit is not asking you what the value is at that point. It's saying, what is the graph going towards? And on the left side, the graph is going towards 1. It doesn't ever equal 1, but that's what it's approaching. It's approaching 1. That's what that means. So it's approaching 1. So that's why the limit here is 1. Where on the right side, coming in from the right, the the y value is pretty constant at 2. Or sorry, at 3. That's 3. So for the first one, my answer for A is 3. The answer for part B is 1. The answer for part C is 2. Now, if they don't match, notice how the left and the right, they're not the same. Oh, sorry. Wait, what did I do? Oh, that should be a 3. Thank you. I know that's what you're like. Wait, that's a 3, y'all. 3. Okay. So notice that the left and the right are not the same. What the left side is doing is not the same as the right side, which is why I had you write this definition. If at that point the left and right are not the same, then the limit does not exist. So for part D, we would say is D and E. What kind of discontinuity do we have right here? Jumps. Can you write that all jumps, if it's a jump, it does not exist at that point. A jump discontinuity is at that point, it is undefined. All right, let's look at E. E is asking for when X is 3. So when X is 3, what is Y? Does everyone see? At 3. At 3, it's 2. Now, if I were to draw this little wall here, on the left side of the wall, the graph is hitting right here, which is what? What's the Y value right here where I have my red dot? 3. On the right side, what is it hitting? The right side of the wall is hitting right here, and that's 2. It didn't ask for the limit at 3, but if it did ask for the limit at 3, what would we say? Does not exist, because that's another jump. All right, G of 4. So at 4, we don't have a discontinuity. So what is my Y value when X is 4? 3. The limit is also 3. On both sides of the wall, it would hit at 3. So the limit would be 3. All right, let's look at another graph. We're just going to look at graphs. We got a lot of graphs we're going to look at and just determine limits. Looking at graphs. All kind of graphs. All right, let's look at the first one. The limit as X approaches 4. All right, so this is 4. This is 4 right here. It looks like it's continuous at that point, right? What is the Y value? 2. Now this is saying 3 from the left. So 3 from the left. So positive 3 from the left. So I have a wall. What is the graph doing on the left side of that wall? You said what? Not. It's going down. Does everyone see that? So that means that the limit would be what? If it's going down, what do you think it would be? Negative infinity. All right, what about the right side of the wall? It's right here. What's the Y value right there? 2. Now, at 3, did I write the same thing for the left and right? On the left side, I said it was negative infinity. On the right side, I said it's 2. Remember, these have to match. And if they don't match, what do we say? Does not exist. All right, let's look at 5. This says 0 from the left. So this is 0. On the left side of 0, the arrow is going down. On the right side of 0, what is the arrow doing? Going up. Did I write the same thing for the left and right? No, so that means at 0, it does not exist. What kind of discontinuity do we have at x equals 0? Infinite, yep. All right, anytime it asks you for positive infinity, that's asking you for the right arrow. That's what positive infinity is asking. The right arrow, we only have the furthest right arrow would be this one right here. And what is that right arrow doing? It looks like it's constant. It's constant at what? What'd you say, Toby? Positive what? Well, it's constant. It looks like it's just going straight. It doesn't look like it's going up or down. It's just going straight. So what is it going straight at? Y equals what? 4. If it looked like the arrow was pointing upwards, we would say positive infinity. If it was going down, we would say negative infinity. This one is just going straight, so the limit is 4. All right, but on the left arrow, so the negative infinity, this means the left arrow. So that would be this arrow. What is that arrow doing? What would you say, Liliana? What is that arrow doing on the left? Going up. So we would say our limit is what? Positive infinity. Good job. All right, -2. Now, -2, what kind of discontinuity do we have at -2? A removable. Removables have a limit. They do have a limit. And the reason why is because if I were to draw a line, do you agree that the left side and the right side are hitting the wall at the same place? That's why a removable has a limit. So even though it's undefined at -2, the limit still exists because a limit is asking you what it approaches, not what it equals. So the graph is approaching 3 on the left and right side, so the limit would be 3. All right, the limit at 5. At 5, if I were to draw my little wall here at 5, do you agree that the graph does not hit at the same place on the left and right side? What kind of discontinuity do we have there? That's a jump. So they're hitting at 2 different y values. So that means at that point, we don't have a limit. It does not exist. All right, -5. So if I were to draw a wall here at -5, -5 is continuous. We don't have anything happening here. So this we got to kind of approximate it, but I'm going to say that the limit is -0.5. -1/2. Limits is one of those things that you just have to practice. You have to fall down, then you have to get up, and then you'll get better. All right, at x equals 0, what kind of discontinuity do we have here at x equals 0? Infinite, good. At x equals -2, what kind of discontinuity do we have where I drew that pink line? Removable. And then at x equals +5, which is where I'm drawing this green line, what do we call that? That's a jump. Okay. So I just want you all to try to do A, B, and C by yourself. And then we'll go through it together. Try to do A, B, and C by yourself. just take a guess, pick a number. Okay, so let's see if we got it. Limits should not take a lot of time because you're just literally looking at a graph. You're not plugging in anything. You're just looking at a graph, making an assessment. So first of all, I'm looking at 3. So I like to, and this is optional, I just kind of like to draw in right here at the 3. Now, this is asking you for the left side. See how it has a little minus sign afterwards? This is left, this is right. On the left side, where does the graph hit the wall? At 1. On the right side, where does it hit the wall? 0. At 3, what are we going to say? D and E. Who had that? Okay. All right, now try to do D, E, F, and G. Okay, I see people click-clacking on the phone, so I guess that means we're ready. All right, at the 3, this is asking you where's your close point. So where's my close point at 3? Is it at the 0 or is it at 1? So the answer would be 1. Okay, E is tricky because it didn't ask you for, so E and F look similar, but they're not the same. So E is asking you for the limit. What do you think the limit would be at E? Who said 1? Who says does not exist? Does not exist. And the reason why it does not exist is because, remember, what did I say? The left and the right side have to do the same thing. There's nothing happening on the right. That's the end of the road. So we don't have a limit at 4. There's no limit at 4. But the answer to F is 1. The answer to E is does not exist. G, the limit as x approaches 1. Okay, so this is our removable. But if I draw my wall, notice that the left and the right side are hitting the wall at the same place. So the answer would be 5. Are we catching on? It look kind of crazy, but it's not. Let's keep going. Okay, so what this is asking you for, when it says limit as x approaches negative infinity and as x approaches positive infinity. So you do have to write this you have to write the limit as an end behavior. So the first thing you're going to do is I'm just going to write that end behavior statement. I'm just going to put mine above and below it because I don't have, well, I guess I could have made some space. Actually, that's what I'll do. I'll make space. All right, so let's go ahead and write that limit statement. So the first one is the limit of f of x as x approaches negative infinity, and then the limit of f of x as x approaches positive infinity. So for this graph, the left side, so this is the left, this means the right. So on this graph, the left side goes down, which means my limit would be negative infinity. And on the right side, which is this side, is going up. So my limit would be positive infinity. That would be my answers. All right, let's look at the next one. So on this one, the left side is going up. So that would be positive infinity. The right side is going down, so that would be a negative infinity. Now, these two we call even because they're doing the same thing. So we can write our limit as one statement. So I'm going to say the limit as x approaches positive and negative infinity. Since they're doing the same thing, we don't have to separate them. The limit as x approaches positive and negative infinity is positive infinity because both sides are going up. And for this one, oh, I forgot to put f of x. The limit of f of x is positive infinity. And for the last one, we would say the limit of f of x as x approaches plus and minus infinity. What is it doing on both sides? Going down, so it would be what? Negative infinity. So just remember, if it's asking you for infinity, that means we're looking at the arrows. Okay. I'm going to give you a couple minutes to do numbers 1 through 10 by yourself. Just take a guess. And they go pretty fast. When you have 1 through 10 finished, just put your pencils down. Then I'm just gonna have you circle the ones you missed. So take a guess, 1 through 10. All right, let's go through it. So what did you all put? So first of all, I like to draw a wall. I'm going to draw my wall at -5. Okay. So what did you put? 1, 2, and 3 should be the same because it's a removable discontinuity. So what answer did you put for numbers 1, 2, and 3? 2. Removables have a limit. It's a removable. But f of -5 is where the closed dot is. And that's 1. All right, now we're going to -2. So -2. I'm gonna draw my little wall in right here. So we got a jump. So on the left side of my purple wall, where is the graph hitting the purple wall on the left side? -1. But on the right side, this is the graph, is hitting here at +4, which means at that place, it does not exist because the left and right don't agree, and my closed dot is at 2. All right, lastly for today, we got 0. So 0 is here. 0 is continuous. So for 0, we should have the same answer, which is what? Where is the graph touching my green wall at 0? 6. All right, who got at least 7 right out of those 10? Okay. So I'm going to have you all continue working. We're not going to go through them today, but I want you to continue working through 11 through 29. And then tomorrow we will go through those answers.